Alright, last subtopic for this chapter, which is on satellite motion in a circular orbit. So in this subtopic, you should be able to use escape velocity and then derive and use the equation for satellite motion, where you have to derive velocity and period and then use it lah to solve questions or problems, right? So escape velocity, what is actually escape velocity? If an object is projected upward from the Earth's surface with a large enough speed, it can actually soar off into space and never return. Okay, for example, kita ada, this is our Earth, and then we want to launch a rocket. Okay, mau launch a rocket, boleh lah tu begitu. Okay, in order for it to escape the Earth's punya atmosphere, we have to calculate the escape velocity dulu. Okay, so we have to find the escape velocity in order for this rocket to go up, soar off the Earth's atmosphere and into the space. Okay, so when it goes into the space, it will never return back to the Earth lah. Okay. Okay, so that speed is known as the escape velocity. Okay, so it can be found by applying the conservation of energy. So this one is just the derivation on how to obtain this equation, but you don't really have to know the derivation, you just have to know how to use it. But if you want to know how the escape velocity is obtained, this here is the derivation lah. Okay, basically it applies the conservation of energy and then it neglects the air resistance, assuming the initial velocity is just large enough to allow the object to reach infinite with a speed of 0. Okay, so they let several variables to be equal to 0, and then they come up with this equation. I mean, they sorry. Basically, they just they have what is left to be just the kinetic energy as well as the potential energy. Okay, so this initial velocity here, velocity is known as the escape velocity lah. After rearranging and then substitution, you will then get the formula for the escape velocity as this one. Alright. Okay, so now you have to be able to use this velocity, escape velocity punya formula. So G here is the gravitational constant, ME is the mass of the Earth, whereas capital R here is the radius of the Earth lah. Okay. Alright, so now linear velocity. So this one you have to be able to derive lah untuk dapat this equation. Okay, so let's consider a satellite of mass m. So this is the satellite traveling around the Earth of mass m, and then other radius capital R. Okay. And then circular orbit of radius r. So this is r. Lepas tu, it is traveling with constant tangential velocity. Tangential velocity is basically the linear velocity. This one. Okay, so the centripetal force contributed by this gravitational force of attraction F can be written as this formula here. Okay, so this is the circular motion punya formula. Okay, and then we know that the force, the centripetal force that is present in the satellite is only the gravitational force lah. Okay, so this gravitational force, we know that the equation is equal to GMM. I feel like this one should be capital M. This is not salah lagi. This one is GMM over R square. It's not dia bukan M and then subscript ke superscript? Subscript, I think. Dia bukan small m di bawah tu lah. Okay, so it's in one line. Okay, so this is the gravitational force. It let equal to MAC, which is mv square over r. Okay, so apa yang kamu perlu ingat, it is the gravitational force equal to mv square over r lah. Okay, so rearrange and then you will then get the tangential velocity to be equal to this formula here. this one. Okay, alright, so the r here is the distance of the satellite from the center. Okay, from the center of the earth. M is the mass of the earth, and then G is the universal gravitational constant lah. Okay, so if the satellite is close to the earth's surface, where we can let the distance to be equal to the radius of the earth, we then can have the the tangential velocity to be equal to the square root of gr lah. Okay, and then from here we can then find the period of the satellite. So we know that tangential velocity can be related to the angular velocity, which is equal to VR omega. Okay, and then we know that omega is equal to 2 pi r over t pula. Okay, so from here we can then find the value of t, which is, find the equation for t. So kamu rearrange, you should get this lah. Should get the period as this equation here. Okay, alright, so that is basically the theory part for satellite motion in a circular orbit.